Hello guys, my name is Craig and welcome to Peri Solutions. If you're new to my channel, please make sure you subscribe and hit the notification bell so that you don't miss out on any new videos. In today's video, we're going to talk about the chord of a circle. Right, so we need to study this circle here. Right, so as you can see, from this circle, we've got a line AB that is cutting the circle into two sections. So we've got this part and this part. So this line AB is what we call the chord of a circle, right? This is a line that will cut a circle and divide it into sections, probably two parts, right? So this unshaded part is what we call the major segment. And then this shaded part is what we call the minor segment, right? And as well as you can see that a line from the center, right, to the midpoint of the chord AB, what this line does is that it bisects the angle subtended by the chord at the center of the circle. In other words, this angle subtended at the center by the chord, right? This angle here is being cut into half, into two halves by that line. As long as it's getting to the midpoint of the chord, in as well at this midpoint, it bisects the chord at right angles, right? So now we just like to look at how we would then apply what we've been talking about, calculating the area of a sector, calculating the area of a triangle. Now we need to see where it applies. So now with number one, say we've got this circle and then we've got a triangle inside, XY being a segment of length 12 centimeters in such a way that M would be the midpoint, right? And then this is the radius 10, and then as well here 10 centimeters. So the first part requires us to find the angle XOM. So XOM is this angle that we want. This one. This is the angle that we want. But as we can see, we've got two right angled triangles. So this implies that from the first one, we can calculate this angle, right? Of course, this angle is the same as that angle. So you can just multiply this angle, then multiply it by 2, right? So if we need this angle, let's call it theta, right? Theta, this being the hypotenuse side, and this being the opposite side. It means we can use the sine ratio, right? Such that for the first part, 1a, we're saying that sine theta is equal to the opposite side over the hypotenuse side. And theta will be arc sine of 0.6, which would be equal to, let me get my calculator. So arc sine of 0.6, that will give us 36.9. So 36.9, confirm, yes, 36.9 degrees. So it's that angle. But we know this and this, those are two equal angles. Say that X or Y would be equal to 36.9 times 2, which would give us 36.9 times 2. That would give us 73.8. Sorry. So 73.8 degrees. This would be the angle X or Y. Now part B requires us to find the area of the minor segment. So if XY is our chord, this is the major segment, then this bottom part is the minor segment. So allow me to just shade it in blue there. Right. So that's what we want. So now to find that area, what I'm going to do is that we're going to say the area of this whole sector, right? This whole sector minus the area of this triangle to get the shaded area. So we say the area of a sector is given by theta over 360 times pi r squared, then minus area of this triangle, x or y, we're saying half AB, but in this case that's radius squared, sine of theta, sine of this, let's say 2 theta, yeah. Let me say x or y, like this. So this will give us the area of the shaded This will give us the area of the shaded region. So we're saying, now if you to substitute, we got our theta, which is this angle, right? The whole of this angle. We got it as 73.8. So 73.8 over 360 times pi r squared. Radius is 10. 10 squared, that will give us 100. Minus 1 over 2. R squared, that's 100. Sine of the angle x or y, which is 73.8. So now if we calculate that, we will get an answer of say 73.8 pi times 100 divided by 360. We get 41 over 2 pi, then minus 50 sine of 73.8. That's minus 48, putting the 0, right, such that minus 48.0, 48, that will give us 16.4. So 16.4 sway centimeters. This would be the area of this minor segment. And please take note that theta over 360 pi r squared is the area, is the formula that we use for finding the sector area. So in this case, our theta for this sector is the whole of this angle, which we calculated to be 73.8, right? Yes, so that's how we do that. Now moving on to number 2. So allow me to erase this part and leave. Okay, so moving on to number 2. First part, it requires us to find the length of AB. Right. So first part requires us to find the length of AB. AB being that. But what do we know? We know that OA is the radius, OB is the radius. So OB is also 8 centimeters. And then now finding AB, we've got 2 sides in the included angle. So definitely we use the cosine rule for side. So we're saying for number 2A, cosine rule for sides, we're saying AB squared is equal to 8 squared plus 8 squared minus 2, 8 times 8 cos of the angle 130 degrees, which means AB will be equal to the root of 64 plus 64. That gives us 128 minus 128 cos of 130 degrees, like that. And then we can further on simplify this to get 128 minus 128 cos of 130. That will give us, in the root of that will give us 14.5. So 14.5 centimeters would be the length of AB. And then part B requires us to find the area of sector OAB. So area of the sector, we say theta being 130 over 360 times pi r squared, r being 8 squared, that will give us 64. And this will give us 130 times 64 pi, then divided by 360, that will give us 72.6. So 72.6 square centimeters. This would be the area of the sector OAB, this whole sector. And then part C requires us to find the area of triangle OAB, which we say area is half AB, right? A and B being the radius, so that's radius squared, sine of theta, which means half 8 squared, that will give us 64, sine of 130. And this will give us an answer of 32 sine 130. That is equal to 24.5. So 24.5 square centimeters as well. This would be the area of this triangle. And then part D requires us to find the area of the minor segment. So area of the minor segment, if AB is the chord, that's the major segment, and then the bottom part is the minor segment. In other words, the shaded region. So we are now simply saying the area of this whole sector, sector OAB, minus area of the triangle OAB. Right. So that will be 72.6 minus 24.5. Right, to give us 48.1. Let me just confirm. Minus 24. Yes, that will give us 48.1 square centimeters. So this would be the area of the minor segment. Okay, so this was simply just looking at the chord of a circle and how we would apply various formulae of trigonometry. Applying the formula for finding the sector of a circle, the area of the sector of a circle, the arc length, the area of a triangle, that is not a right angle triangle, applying basic trigonometry, right? Sine, cos, and tan. So please, feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.